In example one, we're going to use the graph of the function f of x to answer each question, which is on the right-hand side, a through h. We'll use infinity, negative infinity, or even does not exist where appropriate. Now, if we look at part A, B, and C, there's no limit notation. So A, B, and C are just function evaluation. Let's see if we can figure out what f at 0 is. F at 0 would be the output when x is 0. But there isn't one. So we should write undefined. The open circle, remember, means that the function does not actually have a y value there. So if we continue on here, we've got f at 2. So let's try f at 2. We'll try to erase a few of these marks here. And we can look at f at 2, and there is a point right here, and that point is 2, 0. So the output when x is 2 is 0. And f at 3 is this point right here. You want to look for any solid part of a line, or you want to look for a filled in circle indicating that point does exist. And it looks like that output is 3. So that's 3 comma 3 right over there. And now things are going to change a little bit. So we're looking for now d through h. That's going to be limit notation. So let's try the first one. The limit as x approaches 0 from the left. All right, well, there's no arrowhead on here, but we're going to go ahead and put one there anyways. And so what's happening if we continue all the way to try to get closer to 0, this function continues down forever. So we would write this as negative infinity, or because infinity or negative infinity is not a number, you could even write does not exist. Either one is acceptable. The limit as x approaches 0, and there's no plus or minus sign here. We're looking at part E now. That means it's a two-sided limit. So the limit from the left has to be the same as the limit from the right. And we're just not approaching the same thing here. So we have to write d and e. It would not be appropriate to write infinity or negative infinity here. When we write infinity or negative infinity, it's just a description of where the values are going. But because the limit is not the same from the left as it is from the right, when x approaches 0, we have to write d and e for this one. Part F and G deal with x approaching 3. So let's see if we can figure out as x approaches 3 from the right here, and we'll change colors for you, make it a little bit more readable. So as x approaches 3, we're on part F now. As x approaches 3 from the right, so I'm going to be a point on the graph. I'm going to try to get closer and closer and closer to an x value of 3, and my y value or output approaches 2. Now, we don't care that the actual point there is 3 comma 3. The actual function evaluation when x is 3 would be equal to 3, but that's not the same thing as a limit. For a limit, we're asking the question, what are we approaching or getting close to? Let's talk about the two-sided limit now as x approaches 3. That's part G. And we've already investigated the limit as x approaches 3 from the right. Let's investigate what happens as x approaches 3 from the left. And that appears to be 1. Well, the limit as x approaches 3 from the right is 2, and the limit as x approaches 3 from the left is 1. So the two-sided limit, unfortunately, again, does not exist here. Now let's talk about this one. We haven't done one with infinity just quite yet. If you've already looked at the previous example, we went through a graphical one similar to this one, but we didn't do anything with infinity or negative infinity. So let's talk about that now. We're on part H. This is the limit as x approaches negative infinity of that function. So we want to make x as small as we possibly can, or as negative as we possibly can, I should say. So if we do that, it looks like there's this horizontal asymptote right here that we'll never reach, but we will approach or get close to it. So if we think about this in the same way, even though the function will never actually have a y value of 1 on the left-hand side, we don't care for a limit. We just care about what that function is approaching or getting close to. And the more negative we go, the more we increase in the negative direction, the closer and closer we get to 1. So the answer to this limit question for part H is definitely 1.